Hi, today I'm going to review how to factor. So one of the first things that you do when you're factoring is you look for a GCF. That's your greatest common factor. And this is a step that a lot of people forget to do and they end up with a lot more work. So what you want to look for right away is if each term has something in common, some multiple in common. We'll make that 12. X to the 4th minus 10 x to the 7th, and we'll just throw in a y for fun. So what we're going to do is we're going to look at these numbers and see, is there anything that can divide in evenly into all those? Well, yeah, a 2 can. All right, so then I'm going to break down what's left over inside the parentheses. Then we're going to go to our variables. Do they have any variables in common? Yeah, they have an x in common. They don't just have one x, they actually have 3 x's in common. So there's a 3 here, 3 x's here, here, and here. When I divide that out, what I'll be left with, 6x cubed divided by 2x cubed is going to be 3. Right? And then, or you could ask yourself, what do I need to multiply this by to get that? I need to multiply by 6x. What do I need to multiply this by to get that? A 5x. Now, I need 4 x's to make up the rest to get to 7. And then I never did anything with the y's. So I'm left with that. So this right here is your GCF. And what typically happens is this becomes a little bit easier to work with, which sometimes then becomes factorable, which then brings me to the next part. All right, what if you're left with just 2 terms? So you've seen this last year as something that might look like this, a squared minus b squared. That factors. This is our difference of squares. So this would be a plus b, a minus b. Right, the next one, maybe not so common. If you just did squares, the next one might be difference of cubes, or even the sum of cubes. This one didn't have a sum of squares. There was no special property. All right, and this is actually factorable as well. So this becomes a minus b, a squared plus ab plus b squared. And this one is a plus b. The sign's going to change here too. A squared minus ab plus b squared. So this would be a difference of cubes. And this would be a difference. Oh, not a difference. This would be a sum of cubes. These formulas are kind of useful, so you might want to stick them into your notes somewhere to grab when you need them. All right. And this next one you've done a ton of, and this is when you had 3 terms. And this is using a diamond and a box. So the diamond box method is taking a trinomial like 3x squared plus 5x minus 12, and you need to factor it. You should realize that your final answer is going to look like this in some kind of parentheses if you're asked to factor it, or if it's factorable. So the first thing that you did was you drew the box. The 3x squared went there, the minus 12 went there, and then the goal was to find out what went here and here. So that's where you use the diamond. So in the diamond, I believe you multiply these two together. So you got negative 36x squared. And then this middle term went down here. So you had to ask yourself, what 2 numbers multiply to negative 36 and add to 5? So that would be 9x and negative 4x. So those 2 numbers went here. And again, now we just factored. So what do these have in common? They have nothing in common. So this would just be an x. This has a 3x in common. This has a negative 4 in common. And this has a 3 in common. So you're just factoring. This is like the GCF of that. So your final answer is going to be 3x minus 4, x plus 3. So this is the factored form of that trinomial.